Hope you all are enjoying your semester so far. It looks like we're kind of in the heat of midterm season, so thank you all for taking the time to be here this week. Today, we're going to be going over the basics of data science in Python. Specifically, we're going to be looking at the NumPy library, which is very useful for a lot of mathematical operations. Uh, Next week, we'll get into some other libraries that we can use, but for now, we're just going to start with the basics. NumPy is probably the single most popular library in Python. It has a lot of really useful tools that let you do stuff more efficiently, easier to write than base Python, and also runs faster for a lot of applications. So yeah, we'll just get into that now. So first of all, what is NumPy? Well, as I mentioned, it's a library in Python. It's meant for numerical computing. So when you have a bunch of numbers in an array or a matrix or something, and you just want to do some basic math on them. So it provides a way for us to do things in memory efficient ways. So but Python's default array is kind of not memory efficient. It's not very fast. It's very easy to use. It's very writable, flexible, but it's just not really optimized for having a large amounts of data. So if you're talking about uh, incorporating like billions of pieces of data all at once, you probably want to use NumPy or Pandas or some other library instead of just sticking it right into Python. It's also really common in AI, data science, and scientific computing. So again, anything where you have large amounts of data that you're working with, NumPy is going to come in handy. So as I mentioned, it's faster than Python list. It also supports vectorized operations, meaning, for example, if you have a list of numbers, let's say a list of 1,000 different numbers, that's called a vector, and you can do an operation like adding a certain number to every element at the same time. So you can like take the array and add five, and it adds five to every element, rather than having to make a loop and going through each element and adding it. So it makes it a lot easier to write. You can also do that with multiplication and other basic operations. It has a lot of built-in math and statistics functions, which again makes your life easier as a programmer. So that'll definitely come in handy. So let's just look at some examples of how we can create arrays in NumPy. So in general, if you're working with small amounts of data, you might just explicitly program it. So I'll get to a programming exercise in a second, but for now, I'll just go over the basics. So you can define an array using uh, NP, which is NumPy. So you import the library as NP dot array, and then you pass in actually a Python list. So here's the list, which has square brackets containing the elements 1, 2, and 3, and you're turning that into a NumPy array. So that's just a basic one-dimensional array, meaning it's essentially a list or a vector. Uh, and then if you want a two-dimensional array, you do the same thing, except you enter two different. I think I'm actually missing so I'm missing some square brackets here. Should be an extra pair of square brackets. Yeah. Uh, so you pass in a list that contains two lists, each having numbers, and that lets you use it as a two-dimensional array, which is like a matrix almost. So if you think of it like 1, 2, 3 is like the first row of your matrix, then 7, 8, 9 is the second row. So really what this would look like, it's like 1, 2, 3, 7, 8, 9 as a matrix. For those of you who've taken the algebra, I'll maybe get the other one, but yeah, pretty straightforward. You can index any value by first indexing which row it's in, so which of these sublists, and then which element it is. So if you index it at 0, 0, it'll take you to the first um, the first row and then the first element. Or if you do it at 1, comma 2, one's technically here, the 2 would be 9 because you start indexing at 0. So yeah, that's just basic idea how you define arrays in 1 or 2 dimensions. You can also create certain special arrays. For example, if you implement zeros, it just creates an array full of zeros, as the name suggests. So this is a 2 by 3 here, so that's like a 2 by 3 matrix. It means 2 rows and 3 columns, so the same shape but all full of zeros. You can also do it with NumPy.ones, which again just fills it with ones, and that could be useful if you're trying to do certain manipulation without having to loop through it to find out. Actually, it saves a lot of time. Um, yeah. So We can also use NumPy for indexing and slicing, which means, I mean, any array, of course, you want to be able to look at the elements of it. So if you index an array at 0, you get the first element. If you index it at 5, you get technically the sixth element. But uh, I'm sure you've all seen that before in some context. So yeah, it works the same in NumPy. You can also splice an array. So you can say, I want everything from the first to the fourth element. And that's just the syntax. You go from 1, colon 4. It just kind of makes a subset of it. And you can also modify elements in the same way you're probably used to, just array at that index equals whatever the new value is. As I mentioned earlier, NumPy lets you do element-wise operations, meaning that you can do stuff to the array in a way that affects all of the values of it without having to do a loop through each element. So, for example, you can take the square root of an array, and that finds the square root of each value in a new array. You can also find the logarithm or other features. Uh, yeah, and you can also do stuff by like adding arrays, multiplying them together, and all that. So yeah, a lot of useful tools. And then there's also some statistical tools. If you have an array, you can find the mean of it, standard deviation, and also the sum of the array. So that's really useful if you're doing something in statistical context or otherwise. Um, and then there's also axis-wise operations, which basically means if you have a multidimensional data, like a matrix, you can say if the axis is 0 here, you're looking at the 0th row and just finding the sum of that. So it's yeah, fairly straightforward. You're just kind of looking at a piece of it. So if you wanted the sum of the second row, you can set the axis equal 1 and so on. So now let's take a look at a coding challenge. I'll put this link in the Discord real quick. Actually, I'm making a copy. Yeah, whatever. I'll just. Oh, Jason. All right, so I sent that out in the Discord announcements. You should all be able to access that now. When you get to that page, it should prompt you to make a copy, I believe. Yeah, or maybe you'll be able to edit it directly. We've used Colabs in past in this club, but any of you have not used it before. Basically, it's just a way you can run Python in a web browser, and you can kind of run it little pieces at a time. So basically, the way that this lab will work is at first it walks you through a few functions, kind of just fill in the blanks to get the hang of what the syntax looks like and how to use it. And then there's the challenge at the bottom where you're given some data, some of course made up data about the stock market, and you're going to do a few tests to analyze it, like finding the mean and standard deviation, and also calculating things like market cap. So yeah, this would be a fun exercise for you guys. So yeah, does anyone not have this pulled up yet? Does anyone need help setting up the full lab or anything? Yeah, so just let me know if you need any help. Other than that, I'll let you guys work. And yeah, again, if you have any questions, let me know and I'll come over and help. So yeah. Does anyone have it up? Like, are you able to do that? Okay. Yeah. So yeah, just go ahead and make a copy and it should be all good. Does anyone want to see me walk through the first few exercises or do you want to do it on your own? Well, I mean, uh, yeah, I mean, The first few exercises are not too bad. You're literally just filling in the blanks. It's an iterable, but it's not a list, so it doesn't generate them all out. It just lets you go through it, like that's as you go through it. So I'm gonna check that out, see if that works. Oh, oh yeah. Make sure that you run the first block of code to import NumPy. If you don't do that, then nothing's gonna work. Also, another note, I would recommend that after you define each function, I uh I should have had a line to do this, but you should actually try calling the function just to make sure it works. So like if I define create 2D array, I can just type in create 2D array at the bottom. And then when I run it, it'll give me an error if I messed up, or it'll run it successfully if I did it right. So yeah, just for each one, if you just repeat the name of this function that you're trying to call. If you put it down here, then they'll actually run it. Otherwise, you're just defining a function without running it, and there's no output. And then it should put your outputs down here. I thought they were had options. And it's awesome because like that's like for me at least I like wanted yeah, and that's kind of all right. So it's like it was a bunch of people. I didn't put together on stuff. But I actually wanted to I didn't know